Good morning. We are going to be getting started shortly. So first, a few administrative things before we get going. First, a copy of this webinar is being recorded. So afterwards, everyone will get a link and it will be made available. So if you miss any part of it or want to share it with other members in your organization, that will be done. Throughout this webinar, I will briefly pause for questions. If you have a question anytime throughout, there is actually in the go-to meeting control an ability to post a question that you want to ask. So feel free to ask. Now, if during the presentation your question is answered, you can also withdraw the question and everything shall be fine. So we're going to get started right now. So what's exciting today and why we're all here is to learn about the recent FCC report and order that just came out back in August that allows for smaller dishes and wider channels in the 6, 11, 18, and 23 gigahertz bands. I'm going to make some basic assumptions of the audience here, but for people who are new or who may not be as familiar with everything, Part 101 is the FCC rules that deal with licensed microwave backhaul. And for the past couple of years, there have been a bunch of proceedings and discussions about how to adjust and modify Part 101 rules to better facilitate broadband adoption in both rural and suburban and urban markets out there. In early August, a second report and order was issued that allowed for smaller antennas and larger channels in the Part 101 bands. Now, this document here is of public record. So anyone who wants to, you can go to the FCC's website at wireless.fcc.gov and download the 70 or 80 page document if you have more questions or really want to get into the meat of the discussion of what's going on. What we are going to address in this webinar are we are going to hit the high points of what's useful and necessary to service providers and operators such as yourselves, and hopefully save you the time of having to read and digest 70 or 80 pages on what's going on. So today's agenda is fairly straightforward. We're going to talk about first providing an executive summary of the second report and order from 10-153. Secondly, we're going to talk about ways customers, operators like yourself, can take advantage of this new and updated ruling. Then we're going to dive into some real-world customer applications, which definitely goes in with number 2 that we'll discuss how customers can take advantage. And then just for people who may not be as familiar with microwave backhaul, we're going to talk about our Apex 9 microwave backhaul solution and how it is changing or how it applies given the updated Part 101 rules that have been released recently. Finally, we have some time for Q&A. So anything that is not addressed or anything, if you guys have specific questions, and it can be microwave related, Part 101 related, or just general items that you want to discuss, feel free to ask, and I will do my best to address whatever outstanding questions you have. So there are some basic assumptions that I'm going to make of the audience because a full discourse on Part 101 and all the FCC rules and the concept of microwave backhaul would take a lot of time and would probably be redundant for a lot of the audience. So for people who know this, this is just kind of a 2-minute catch-up for everybody. For people who are new, hopefully this will give you a backdrop in terms of what we're discussing. So Part 101 is the portion of the FCC rules that deals with licensed microwave backhaul. And for many people, we've all are familiar with backhaul. People use lease lines. They might use T1s, or they might use a variety of landline technologies. Wireless has the ability to deliver high amounts of bandwidth, sometimes in excess of a gigabit per second. And specifically, there are several licensed bands that fall under Part 101 of the FCC rules that are available for private operators and common carriers to license so that they can deploy their backhaul networks with FCC-protected spectrum. Essentially, the benefits of licensing is you have greater amounts of capacity, and there are no needs to worry about interference because your channels will be licensed. The major bands available for licensed microwave backhaul are the 6 gigahertz, 11, 18, and 23 gigahertz bands. Through a recent rule and report and order that was released last year, portions of the 7 and 13 gigahertz bands are also available now for microwave backhaul licensing. So let's get into the meat of 10153, what they're talking about, and where everyone's trying to go. So the FCC, and this is in conjunction with governmental policy and all the election stuff going on, has concluded through the National Broadband Plan that we need to catch up on broadband with the rest of the world. I don't know the recent number, but I recall reading a news headline that the U.S. was 13th out of the world in terms of broadband adoption or speeds or something, and this came out back in 2008 and 2009. So with all this, there was the broadband stimulus plan, there were a bunch of things, and this rulemaking and these discussions related to Part 101 are all related to facilitating or answering the question of how do we get more broadband out there, or what can we do on a regulatory side to allow operators in both rural areas and urban areas to cost-effectively deploy broadband so we get it out faster for everybody. So this addresses specifically microwave backhaul, which are its technology used to transmit data between perhaps tower sites and to network backbones. More and more, people are using microwave as an alternative to traditional copper and fiber optic links, and especially in rural or areas where that are hard to reach, perhaps the other side of a train track, across right-of-way issues. Microwave is becoming more and more of a accepted and popular solution for the market. So what is being addressed in the second report and order, specifically to Part 101, is they are adjusting the rules so that spectrum can be used and hopefully used more efficiently. They're also addressing the rules to make it more practical to deploy these systems by allowing for smaller antennas. And in the instances where the spectrum is available, they have addressed the rules to allow for higher capacity deployments by creating larger channel sizes in the lower frequencies. So here is the top-level executive overview of the changes that were implemented on August 3rd. So the first thing that's big for everyone is smaller antennas in the 6, 18, and 23 gigahertz band. This is something that smaller antennas has been discussed over the last 5 or 6 years. For people who've been in this business for a long time, back in 2004, we had to use 4-foot dishes for 11 gig and 6-foot dish minimums for 6 gigahertz. And because of those dish size requirements, given how larger dishes create more cost, higher tower rents, create more of an eyesore in the neighborhood, many of the lower frequencies, specifically the 6 and 11 gigahertz bands, were not as widely deployed as they because of the dish size. Big development came about a couple years ago. First, they allowed for 3-foot dishes in the 11 gig bands. Then there were more adjustments or changes to the rules that allowed for even 2-foot dishes in the 11 gigahertz band. And today, 11 gig is probably one of the most widely deployed backhaul frequencies due to the channel size and the more advantageous range propagation characteristics of the frequency. So for a lot of people, they've used 11 gig, but 6 gig represents another band with its superior rain attenuation characteristics that many service providers have not been able to widely deploy yet due to the 6-foot minimum dish size requirement of the band. A 6-foot dish, as everyone knows, is fairly sizable. It creates tower loading problems. It creates wind loading problems. It also increases the cost of tower rents or hard costs of structural tower builds to support those size antennas. So upon discussions that have gone on for the past couple of years, the Part 101 rules now allow for 3-foot antennas under a revised Category B standard. And that we feel for a lot of rural operators where you're going to try to shoot distances in excess of 15 to 20 miles, 6 gig, a 3-foot dish is going to be a pretty substantial development for them. In addition, for more urban or suburban settings, 18 gigahertz had a minimum 2-foot rule prior to this report and order, and 23 gigahertz had a minimum 1-foot rule. And given how a lot of these links are maybe half a mile or 1 mile deployed in maybe urban environments or densely populated areas, allowing for smaller dish sizes in 18 and 23 gigahertz under the Category B standard also makes things more advantageous for deployment. So this is, in my opinion, a very huge development and something that's really going to help facilitate more widespread broadband deployment in definitely the rural areas. Additionally, a second major point that was allowed is in areas where the spectrum is available. Now, 6 gigahertz allows for 60 megahertz channels, and 11 gigahertz allows for 80 megahertz channels. So that is doubling the channel capability in those bands. 18 gigahertz still allows for 80 megahertz channels, but what this translates into is on a single channel, which is ultimately your single radio, you will now be able to deploy and get more bandwidth on your single path, which everyone should be happy talking about. When we start talking about the actual bandwidth numbers or what you're going to get, I'm going to reserve that till later when we get into equipment. We're just talking FCC rules, but I will discuss that, hey, having a 30 megahertz channel versus a 60 megahertz channel, what does that translate into throughput for you on your system as you now go around deploying things? In addition, there were 2 other rules that were, or updates that were made to the rules. One was updated efficiency standards. For many operators, while this is important, it's really a nomenclature issue where traditionally there were bandwidth efficiency rules that were all given in traditional circuit switch technologies. So the rules, your 100 meg radio was translated into a N by DS1 or an M by DS3 or OC3 type system. So now they've changed the efficiency standards for in basically a bits per hertz type manner to account for more IP-based radio systems. This is something that's generally handled by the frequency coordinators anyways, so it really doesn't, I mean, it is a substantial change, but for many operators, it's not a big, it's not noticeable. And then finally, for very rural areas where the efficiency standards may not be met, they've now actually created a formal waiver policy that allows you to license maybe a QPSK or perhaps a QPSK link and get away with smaller dishes to reduce your costs and deploy longer range links with less efficiency. Additionally, they're included with the second report in order is a notice of proposed rulemaking, which means these are other facets or factors that the FCC is considering. For some of you who I'm looking at the list was on our last webinar about a year ago, all the things in this report in order were items addressed under last year's notice of proposed rulemaking. So even though these are changes that have occurred, I'm bringing this up just so you guys can be aware of some of the items that are in the horizon that are going to be addressed. So the first thing is smaller antennas in the 13 gigahertz band. We've discussed 6, 11, 18, and 23 gig. 13 gigahertz, there's some discussions on allowing for smaller antennas in that band also. There's also a discussion for antenna rules regarding specifically how Class B or Category B antennas are handled in the presence of interference. So they're talking about, maybe there are options where instead of having to upgrade from a Class B to a Class A, you can just perhaps reduce the power or upgrade into an intermediate type antenna to mitigate interference. While well, let me take that back. This has repercussions specifically in the new 6 gigahertz band because under these new rules, the 3-foot antenna in 6 gigahertz is now a Class B, while the Class A category is essentially a 6-foot antenna to maintain Category A status. And my assumption, or I have a prediction, I guess, in my crystal ball that more and more 6 gigahertz is going to take a huge upswing because of this 3-foot dish rule. Now, this matters because traditionally, as an area gets congested, if you have antenna that falls under Class B certification or categories, someone else who wants to deploy or someone who claims there might be interference could feasibly force you to upgrade your system from a Class B to a Class A so that they can deploy their system. So if you had a 6 gigahertz link out there with 3-foot dishes and someone after the fact wants to come in and says, well, you're interfering with me, they could, under the old rules, or under the, let me take that back, under the current rules, you would have to upgrade to a 6-foot dish. Now, with what's being proposed, they're saying, well, instead of having to upgrade, if you have extra link budget, maybe you can just back off the power by a little bit. Or if you have to upgrade, instead of going from a 3-foot dish to a 6-foot dish, maybe we can get away with a 4-foot dish, so a lesser non-category A upgrade. So now that we've talked about what changes are being made, let's get into real world and talk about what that means. So in the case, and we are, I guess we are specific to our hardware because that's what we know. If you have an existing 6 gigahertz link out there, and this is an example of a 6 gigahertz link that was installed back in 2010, due to FCC regulations with their 30 megahertz channel limits, the radio platform was limited to about 200 megabits per second of full duplex bandwidth because there was 30 megahertz available, and just with how 256 QAM works and digital signal processing and everything, the most you can put in a 30 megahertz channel is 200 megabits. Now, under these new rules, in the case of our hardware, because we actually didn't separate keys or anything, this operator who has this link in place can go re-coordinate the FCC license for a larger 60 megahertz channel. And because our hardware supports more bandwidth than what was available, after re-coordinating that FCC license, all they would have to do is go into the radio configuration, because even though there was a 30 megahertz channel, our hardware was had the signal processing and the RF components to handle larger channels. So upon getting their newly coordinated 60 megahertz link, or 60 megahertz channel for their 6 gigahertz link, they would log into their radio, just change the selection from a 30 megahertz channel to, say, maybe a 50 or a 56 megahertz channel. And afterwards, they put that in, and they are able to increase the bandwidth of their capacity with just changing the FCC feed. So this is, I guess, for our customers, or customers of ours who have deployed the Apex 9 platform in the 11 and 6 gigahertz band. All of our radios are 350 meg radios on the IDU side, and all of our outdoor units are were actually sized for larger channels, because that's how we did the engineering straight on. So if you have our platform, and with its rules, with a 6 gigahertz link, you would just go through the process to redo your FCC license, and then click on the link. And now that hardware investment in this guy, he put this thing in 2 years ago, so he's thrilled. His platform now has a cost-free, hardware-wise, 75% increase in capacity. So, how has that worked? Well, in the real world, we had a customer back in the fall of 2011 who was upgrading some of their backhauls with licensed 11 gigahertz, with our licensed 11 gigahertz LL1000 platform. And he put the thing in back in October, gave a great testimonial saying, hey, we love the performance and the support of the product in the company. We're very happy with it, and since then he's deployed several other of these backhauls in his network. Well, he got a very pleasant surprise when, basically a year after, maybe about 10 months after or 11 months after he deployed his link, he got a call out of the blue from his sales rep who just said, hey, you're going to tell me thank you. And Nate, who is the network administrator at Door County, said, what are you talking about? And his sales rep, James, said, guess what? The FCC rules have changed, and that backhaul that you bought last year and installed actually has the ability to deliver more bandwidth. Now, the increase isn't as big from 11 gigahertz as it is for 6 gigahertz, because, this is, 2-year-old or a year-old hardware, so it doesn't have the latest and greatest chipsets. But he was still, by just going through the process of updating his FCC license, which Nate is doing right now, he's going to refile with the FCC, re-coordinate. Once that process is done, he can literally just dial into his radio and upgrade from about 270 meg to 350 meg on his existing hardware platform. So for people out there with Apex 9 radios in the 6 and 11 gigahertz band, you guys are just going to be able to get a free upgrade on your hardware once you change your FCC. For others who have products from different manufacturers, we can't say how they're going to handle it, but hopefully you'll also be able to benefit from this change by getting more bandwidth on your existing links without having to spend more money. So let's just kind of get into the product a little bit and talk about what are the applications of this. So I know some people on this are current Apex, they've deployed Apex 9 products in their network. Some of you may not know, so we'll just give you a quick overview of the product and then talk about the technical specs and what you can now do given the new rules of the FCC ban. So we feel, at least, that Apex 9 is a very interesting solution because we bundled a lot of things from FCC Part 101 licensing to extremely cost-effective chipsets and built an architecture for what we feel was future-proof when we released the product. And in this case, it's we are very lucky that the rules occurred that our hardware investment or the platform that we invested in for our customers, they are literally able to reap the benefits of the growth because of an FCC rule change. So getting into specifics here, why we think this is a good platform. There are some nice benefits. It is a very reliable and high availability platform that operates in licensed backhauls. There is a scalability of the product which is hard to match. How many platforms 2 years after you buy them, get to give you free upgrades without, hardware changes to maximize their capacity. Additionally, we have a roadmap for, reusing as much hardware as we can as the product develops. And we feel for a 350 megabit per second full duplex microwave solution, the Apex 9 offers an incredible ROI with the best total cost of ownership in the market today. Let's get into, what's being offered. So first is of manufacturers out there, we are one of the only organizations that has conducts the Part 101 frequency coordination in-house. So when you purchase products from other manufacturers, they're usually using companies such as ComSearch or Micronet or Radio Dynamics. In our case, our frequency licensing is being done in-house, and that's something that is fairly unique, especially in terms of how we can coordinate the ordering and delivery of these licensed products. Second thing about the licensed backhaul, just some basic specs about it. The product is a 350 megabit per second full duplex product, so at 256 QAM, that's what you're going to get. The way we've packaged the product, we have no license keys or anything in that regard for the product. So, when you buy the hardware, everything's unlocked. There's no power limits. There's nothing. You get everything in the package. There is high power on the product, so we didn't differentiate between a low power product and a high power product. Everything that we ship is full bandwidth and high power, and depending on the frequency, it puts out to 30 dBm, 1 watt of output power at the ODU. We have the ability today for link aggregation, so you can put 2 of these things on the back of a single antenna and double your capacity. So you can then deliver 700 megabits per second of full duplex throughput on a single antenna. So that's 1.4 gig of aggregate. And latency-wise, we have normal mode and an extremely efficient low latency mode that gives us industry-leading latency in the market. So I'm going to stop for a question. Stop for a second, and there is someone who asked a question. And the person basically said, what's the cost on relicensing an existing link? So the cost of relicensing is all FCC related. So depending on your situation, you would need to perform a coordination, the frequency study and the PCN to go acquire your license. And that is a company, we provide that. We also do it on an a la carte basis. So if you have a different manufacturer's radio, you can also contact us for PCN services, or you can contact ComSearch or Micronet or any of the other listed companies I had on the previous slide for frequency coordination services. So that's the licensing service given by a third party, so there's that cost. Some people have been known to try to do it themselves, and that certainly is an option. And then the second part is there's FCC fees. So traditionally, if you're deploying a new link, there is a FCC site application fee that runs about a little over $500 bucks. Off the top of my head, my memory is just a little, I don't know it. So it's about a $500 fee, but because it's an existing link, you would fall under major modification. So that fee is, I believe, $240 per site. So keep in mind this is a per site fee. So Obviously, if you have one link, you have two sites, so you've got to pay that fee for two sites. But if you have two links back to back, that's only 3 sites. So you would only have to pay the modification of $240 on a per site basis, and that's something that just goes directly to the FCC. So answer that question, and we are going to get back to our slides. So yeah, just summing it up with the Apex 9 backhaul, the value proposition is fairly simple. There's a high amount of capacity given, up to 350 meg full duplex on a single radio, or if you double it up to 700 meg full duplex. It's extremely cost effective. I'm not allowed to talk pricing, but compared to many of the other options out there, we are very competitive with everything in the market, and we've been told that we often are more competitive than what's available. There's a lot of cabling flexibility, so we support up to a 2,000-foot differential between the antenna head and the actual indoor unit, so that is nice. In addition, with coaxial cable, our product is more immune for frequency interference and crosstalk, things that occur sometimes when these links are installed on AM or FM towers. So we've had a lot of positive feedback on that side. And also, out of the box, we are high power in our platform, and that's everything that is there. So advantages, all these sorts of great things. Currently the product, and this is the same product that's been shipping for quite some time, 6, 11, 18, and 23 gigahertz band. We actually also support 7 and 13 gigahertz, and I need to update the slide. So yeah, 6, 7, 11, 13, 18, and 23 gigahertz support. Wideband support. Today on our existing platform, we support up to a 60 megahertz channel bandwidth on the ODU. We are currently looking at 80 megahertz for both 11 and 23 gigahertz, but based on the current IDU chipset, we are at the peak of what we can drive in terms of bandwidth, so we haven't gone there yet. In terms of existing modulation schemes, everything up to 256 QAM, high power, and then a variety of other great features like adaptive modulation or ATPC and all those sorts of things that make it very competitive in the market today. So here are the specifications, getting on the technical side of the Apex 9 product, just for some of the more popular bands. Now you see, given how the channels have widened in all the bands, the specifications across the board are pretty nice. So essentially, if you're running 256 QAM, depending on the frequency, be it 18 or 11 or 6 gigahertz, you're able to get about 350 meg or so through the radio platform. So it's always, everyone always talks great specifications, but everyone then says, well, you're the manufacturer. Does this stuff really work? We want to see how it works in the real world. So rather than listening to me pontificate about all these things that the product does, what we did was in January of 2012, we submitted the Apex 9 backhaul at the Animal Farm Users Group. They have a backhaul bake-off that they run every year, and generally for about 3 days in January, a group of around 300 wireless internet service providers and rural operators gather and talk equipment, talk shop, and talk about all these great things. So I'm going to talk to you a little bit about this backhaul bake-off, the testing methodology, and then discuss about how we perform. So the backhaul bake-off, it's a public assessment that's conducted at a neutral site, which is the Animal Farm Users Group, and validated by neutral parties. So it's run by the Beehive Telephone Company, which is a rural telephone company and a rural wireless internet service provider in Utah and northeastern Nevada. And between Beehive and a bunch of other volunteer wireless internet service providers, they came together. They get a bunch of equipment from manufacturers like ourselves, Motorola or Exalt and Ubiquiti, and they run this test. So essentially, 2 tests are conducted. One was to analyze throughput and latency for each of the products tested. So the tests, what we do is they try to measure the maximum capacity in some sort of a real-world test, and also what's the round-trip latency with a bunch of packet sizes and things like that of those tests. So how throughput is tested is they use an RFC 2544 test, which is performed to define the maximum number of frames per second that can be transmitted without any error, and to measure rate-limiting capabilities, if any, of the wireless bridges. What they do is they use a methodology which they start at a maximum frame rate, then they compare the number of transmitted and received frames, and they run a bunch of varying length test times per RFC 2544 to see how much actual throughput is available in the platform. And in that test, tested against a variety of licensed manufacturers, the Apex 9 product came out with a bandwidth efficiency number of, throughput per megahertz of 6.47, which placed us number 1 against the competing brands. The other test that they ran was a latency test. So basically, they did the latency test by measuring and benchmarking the throughput for a variety of frame sizes to ensure that frames were transmitted without being discarded. And using the throughput test, they used a test instrument for a period of 120 seconds to see what the round-trip type latency might be of the platform. And on a fully loaded platform out there, the Apex 9 was number 2 in latency amongst the competitive field out there. More details of this testing and the results can be found online. So at this web address here, www.asmug.com/WYM2012, and there's a spreadsheet with all the data and everything like that. So we are very pleased with these results because our product was being tested head-to-head against products from other manufacturers that are premium or that are positioned as premium products that cost almost, in some cases, 2 or 3 times as much as what the Apex 9 cost, and we were able to perform very well against the competition. So this is just, now that you've seen that it actually tests out pretty well, these are just our own lab results of kind of what sort of latency measures and things we have found. So remember, there are 2 modes of operation. There is a high latency, or not a high latency, a standard latency mode and a low latency mode that is enabled when you strip out some of the error correction and things on that side. And in the standard latency mode, you can see that round-trip time, regardless of packet size, is about 300 to 400 microseconds. So that works out pretty well for everybody. Throughput, so that's the other question of what you can get. Our radios support some level of packet compression. So when you're actually testing with RFC 2544 and running IP packets through, depending on the bandwidth, you can get anywhere from about 310 megs to about 390 megs of throughput on our 350 meg system. So that's all based on compression and things like that. So we'll throw out some frequently asked questions. I guess I probably should even update this. But many of the things people say is first is, Apex 9 is a new product. We've only been out for a couple of years. There are manufacturers like DragonWave or Motorola or guys, Exalt, who've been around for 10 or 15 years. How are you able to compete? And what's good about our product is we are, the Apex 9 product is being positioned as a workhorse product. So this is the Ford or the Chevy product for backhaul. It's not a Ferrari. It's not a Lamborghini out there. So it's not going to do, quadruple DPRM with all sorts of XPIC and things like that. what we did with the product is we said, well, how can we, the market needs a reasonably priced, high capacity, low latency, reliable backhaul product, and that's how Apex 9 has been designed and developed. We are using chipsets that have been in production for 5 or 6 years, and with today, hundreds of radios deployed, and these chipsets, which are deployed in, tens of thousands or hundreds of thousands of systems, there really is no major new product risk to worry about. And, with all the customers that have deployed, they can probably all attest to the reliability of the platform. Going on, people often ask, do I need special antennas or anything, proprietary about the Apex 9 platform? Our platform, we've designed it to use standard RF antenna components and antennas that conform with the REMIC ODU antenna flange, which is the ODU antenna flange that's used by probably about 80 to 85% of the market today, will work with our Apex 9 antennas. What we do recommend, though, is if you're going to use a separate antenna, please consult with our sales and technical and engineering resources so that there are no physical or mechanical problems to worry about in that situation. And then the final question people ask is, do I need any special or crazy cables? And in our case, we just use standard 50-ohm coaxial cable, so anything like LMR 400 that you can pick up and that a lot of people have used and deployed before will work fine on our platform. So again, what we've done to simplify things, our product is all about, the thought is we want it to be fast, smart, and easy. We want to make things simple, so we don't have bandwidth keys that complicates things. We don't have high or low power. We feel bundled in frequency licensing. We were trying to make licensed backhaul simple and easy to deploy and smart to deploy, so you can deploy more of them and get back to growing and running your business. So how to order? It's pretty easy. You just say, hey, you get a link. Don't have to worry about keys. Don't have to worry about licensing. It's all bundled in. You go order an install kit, which has a bunch of the commonly used components, and then you just pick the antennas you need. If you get them from us, that's fine. If you get them elsewhere, that's fine too. And there you go with the link. And it just works. And what we now have these days is happy customers. So again, these radios have now been shipping for quite some time. There are providers. I'm not sure if John's on the webinar, but actually the next person, the next customer testimonial actually is someone on the webinar. So I'm going to have to thank Larry for being a testimonial. But yeah, I mean, it's pretty straightforward. These are backhauls that work. They're very reasonably priced, and you just put them in, you install them, you provide great support, and they just work. And this is actually a person who's attending. So Larry, thank you for being a customer. Thank you for deploying our Apex 9 backhauls, and we hope you continue to use them and are happy with them. Eddie even posted a comment. Thanks. We do love them. They just work. That's always exciting. So that's it. We've discussed changes in the FCC rules. We've discussed how providers like yourself can take advantage of the changes of the FCC rules. And then, to be more specific, we talked about how our platform, the Apex 9 platform, is positioned to address these changes in the FCC rules. So at this point, I'm going to open the floor up for questions. There are a few questions that have already been entered in, so I'm going to answer them right now. But if there are more questions, feel free to go to the question pane, type them in, and I will do my best to help you out and or answer your question. So first question, actually, yeah, this one was addressed as what were the costs on relicensing. Again, it's just the cost of a PCN and a frequency study for an existing link. Depending on the market rates, that is, whatever the market is out there. And then it's the cost of changing the FCC fees, which is $240, I believe, per site. And don't hold me to that, but I know it's less than what it is to file. It's about half of what it is to file a brand new FCC site application. Second question, fairly new to microwave. How do I know what category my area is? You mentioned that the rule changes apply to Category B rural areas. So let's clarify this, because there's actually a few components. First, in the licensing realm, there's what's called Category A and Category B antennas. And those antennas, that specifically deals, well, it's a summary, so anyone who's really a stickler will get me on that. But to summarize, Category A and Category B define the dish size that you need to license your Part 101 backhaul link. So under the current rules, for example, 6 gig only allows, you need a 6-foot dish to fall under Category A. But with the new updated report and order that came out, they now allow for a 3-foot dish. So when talking about Category A versus Category B, it really determines dish size. So if you're deploying a link and you don't want to ever worry about any sorts of changes or updates on that side, you just go the safe course and go Category A and put up a 6-foot dish and call it a day. Now, there's a reality that a 6-foot dish is pretty large. They're also fairly expensive. I mean, they're at least probably double the cost of a 3-foot dish, I would think, if not more. And then there's that annoying thing of recurring tower rent. And I'm not quite sure exactly how it might be in your market, but what I've experienced is the general rule of thumb is it's about $100 a month per antenna foot on the tower. So what that means is if you use a 3-foot dish, that's 3 feet of antenna on a tower, that might be $300 a month to put your 3-foot dish up. But if you want to put a 6-foot dish up, because it's 6 foot, let me take that back, 6 feet of antenna on the tower, that's going to be $600 a month. So now the argument for going Category B starts becoming a little more and more advantageous, because you say, well, not only am I going to be able to buy my dish for maybe half the cost, and now when I install the thing, I only need 1 tower climber on the top instead of 2, and I can get away with a smaller winch and a smaller truck and a smaller crew. In addition, with a 3-foot dish, I might only be paying $300 a month, while with a 6-foot dish, I might only be paying $600 a month. And if you actually read the rules, that was one of the big considerations that the FCC looked at is, hey, by going with 3-foot dishes and having Category B available for 6 gigahertz, it's just going to lower the cost of deploying these things. And if we're talking about facilitating broadband to deployed in rural areas where, because of population density or demographics, the money just isn't there, we need to do what we can on our rules to let people more cost-effectively deliver higher bandwidth and higher capacity solutions to these rural areas. I mean, it's just pretty straightforward. So that's Category B versus Category A. Now, there's also, since you brought up rural, there actually, if you remember, the 4th bullet point on the slideshow talked about there's now this rural waiver request. So what that deals with is, in certain instances, because of, if you remember from point 3, there's the efficiency standard that's required under Part 101 so people don't waste spectrum. In certain rural areas, if it's really rural and maybe you're trying to stretch that link 60 miles, but it's not going to work with the appropriate 4 nines of reliability or 5 nines of reliability at 256 QAM, but you think you could make it work at QPSK instead. Well, under current FCC rules, you cannot deploy it if it doesn't meet that minimum efficiency, bandwidth per hertz efficiency standard that's out there. And what they're now allowing for is if the county is considered rural and, in the report and order and in the rules, there's like a criteria for, well, if it's this and this and this, there's now a process to apply for a waiver to deploy a low-capacity, long-range licensed link in these places to help people save money. So hopefully that answered that question. If you're still confused, let me know, and you can maybe ask the question a different way, and I'll do my best to continue. So next question, can the IDU be mounted outdoors? So today, the IDU is an indoor IDU. Our current plan, because we've had a lot of requests from customers for outdoor IDUs, is to develop actually an outdoor mounted IDU. But to kind of give you guys, I guess this is inside information of our roadmap. We're currently, so our initial product is the LL1000. And that actually uses Provision's 310 chipset in the 350 meg radio. What we're currently working on, which will be introduced probably, we feel, in the next 2 or 3 months, we've just got to finish up some FCC stuff, work out some firmware kinks, make sure that the betas and everything are all working properly. Is we have what's called the LL1337, which is the next generation of the Apex, the LL1000. So the LL1337 is going to be a 400 meg platform from the 350 meg platform. And that's the platform that will, for anyone out there, if you have an existing link, you can just kind of swap out the IDUs and you'll go from a 350 to a 400 meg platform. You can reuse your existing ODUs and your antennas and everything will be good. And possibly we'll even come up with I don't know if we'll have a buyback or a traded program or something. That's still to be debated. Now, after the LL1337 comes out, our next step will actually be to make a hardened version, I guess, of the 1337 that will allow the IDU to be mounted outdoors. And our current time frame is probably sometime realistically, it's probably spring or summer of next year when we're going to get the outdoor one out, because we still need to get the first upgraded chipset version out. We want to deploy it. Even though we're doing a lot of bug testing and firmware testing and working with beta customers, we want to make sure that the platform is solid and working and that we have lots of happy customers, because we don't have we're not really, well, we would prefer not to deal with shipping shoddy hardware. So we've got to get that done, make sure that's working, and then we're going to work on hardening the components probably Q2, Q3 of next year, so we can have an outdoor version of our IDU. So then people can continue just upgrading the IDUs as like the newer chipsets come up with, say 1024 QAM or double XPIC or all those sorts of, wonderful things that people are talking about. So for duplexing 2 radios on 1 antenna, that would require a dual feed antenna, correct? Kind of. Yeah, I mean, the answer is yes, but it's a little different because for Part 101 and most of these slip-fit antennas out there, they're just passive. If you look at the adapters on the back of the antenna, they're basically just passive waveguide flanges, and you would just put the RF signal in there, and the flange takes it, and it reflects off the feed horn, hits the reflector, and there you go. I can't speak for third-party antennas, but every antenna that we've sold and plan on continuing to sell with our Apex 9 backhaul is built so that you can duplex, you can put 2 radios and run one on vertical and one on horizontal on the actual antenna. So that antenna that's just shipped standard if you buy the antennas from us. Now, to physically put 2 radios on the back of an antenna, given the mounting constraints, or I don't want to say constraints, given the mechanical nature of the mounting, we have what's called a dual antenna mount fixture that you would have to put in on the back of the antenna so that you can accommodate 2 of the outdoor units on the antenna. So the answer is to take advantage of, if you decide maybe 2 years down the line you want to upgrade and put 2 radios on the antenna. If you're using our antennas, we've done all the, we're doing a lot of the legwork to make sure that, the antenna, we're trying to anticipate what your needs might be 3 to 4 or 5 years down the line, because ourselves as a company and as a product, a lot of you guys, we've probably been doing business for over 10 years. We're not, a one-shot wonder, sell you something and move on to the next market. Our concept or our ideal is to build you a product that you can use today. 5 years from now, we still want you to be happy with the product, and we'd like to come back to you. And at least for how we design our stuff, when I was able to have one of our sales guys call a customer and say, hey, remember that product you bought from us a year ago? Well, guess what? Your 260 meg radio can now be a 350 megabit radio because of stuff I did and didn't tell you about. That's kind of what we are about as a company, and that's kind of what we want to do. So, we've made sure that every antenna shipped with these things, if they've been bought from us, can handle this dual polarization thing. And if you do that, that's easy. If you have a third-party antenna that you bought and you need to work with us, I guess, feel free to contact our sales and support teams, and our engineering people will try to figure out if there are additional things or changes that are required to support dual radios on a single antenna. So what's an upgrade from one radio to two from a ULS licensing perspective? And the second question is, do you guys do that? So I'll answer the second part. It's easy. Do we do that? The answer is yes, we do. We do everything that ComSearch or Micronet or some of the other Part 101 coordinators do. You don't get listed by the FCC as a coordinator unless you know what you're doing. What's required to go from one radio to two radio? That's simply a function, actually. It's very similar. It's the exact same process as it is to widen your channel. You would just need to have two channels available in the spectrum. So you'd have to, we do the frequency study, and we have to find the second channel for you. And then if it's an existing link, you just do what's called the major modification to your site. So you pay, what, $240 or something, and modify the site, and then now your path is licensed for two channels instead of one channel. Another question. If I deploy a 6 gigahertz link with 3-foot dishes, can another operator deploy another 6 gigahertz link with 4-foot dishes and force me to upgrade my dish size to not create interference? The answer is kind of. So under existing rules, and that's what's being discussed, if you remember, on the notice, the NPRM, the Notice for Proposed Rulemaking slide of what, talking about not having to upgrade your dish size. Under current rules, it's my understanding, and I'd have to refer back to our FCC specialist on this, but if you have a Class B radiator and someone else wants to deploy, and if and only if there are no other channels available, and then they go in, I believe, as Class A, they can then come in and say, well, we've done our frequency study, we've looked at all the channels available, there's nothing available, the only thing available is this channel, and the only way we can make this channel available is if this guy who's on Class B goes to a Class A, they can actually force you to do that under the existing rules today. What's being proposed is the FCC looks at that and says, well, first, that's kind of not, well, I mean, there's questions on, whether that's a nice thing to do, but it may not always be necessary to have to do that sort of an upgrade. So what you can do is say, well, maybe you don't, what they're proposing is saying, well, perhaps it's just lowering the power a little bit. Maybe the interference is only off by 2 dB, and 2 dB doesn't require a 3-foot to a 6-foot antenna size increase. So maybe if we just reduce our power by 2 dB, that solves the interference protection criteria threshold, and now everyone can deploy and we can be happy. So they're proposing that as a possibility, and they're proposing the possibility of, well, if you can't solve it with power, maybe going to an intermediate step that's not a Class A, so say from a 3-foot to a 4-foot dish, would solve the issue. So everything discussed is currently up for debate, and today, if you have a Class B and the other person deploying proves that there is no other channels available in the area, nothing can be done, and the only way they can deploy is by getting you to upgrade to a Class A, then you would be required to upgrade your system from a Class D to a Class A transmitter. Okay, what are max speed capabilities of the current platform, real world, for existing relicensed and new links? So today our platform is a 350 meg platform. Depending, if you remember the packet size thing, depending on how we work, because of how we do compression, it's anywhere from about 310 meg to about 390 meg with the current LL1000 platform today. Today, the ODU is sized for a 60 megahertz channel. So that's we're kind of at the limit of what our hardware can do on that side. What we're coming out with is a updated IDU that will do a 60 megahertz, that will actually be able to drive 400 meg through that 60 megahertz channel instead of just 350 meg. So that's the next thing that's coming out. I said in the next probably 2 or 3 months, the LL1337. And then, we've got the hardened IDU. Then we're looking into ODUs that can drive 80 megahertz and seeing what makes sense. Now, the challenge with all this stuff always is, keeping that cost equation in play. Our goal is to take, our goal, I don't want to say cheapest, but we're trying to produce the most cost-effective radio possible that delivers all the features that the market needs today. If I could sell, if I say, well, I'm going to now try to produce a $20,000 or $30,000 link radio that has all the bells and whistles and everything like that, and there are manufacturers out there doing that, I would easily just jack in 80 megahertz side ODUs and have a platform that does 10, that can support 1024 QAM and do all that sort of stuff. I mean, that's something that is out there, but like I said earlier, our product is that we're not trying to build the latest and greatest because, the difference between, say, our 400 meg radio versus a radio that can do 500 megs and drive all the latest and greatest might be $10,000. And today, we don't feel the market has a need. People want as much bandwidth as possible, but people would like to save $10,000 too. So that's constantly what goes on the engineering side is we're not just, trying to win a science fair award here. We're trying to build products that work and that are reasonable and cost effective so that people can deploy and make money at this, because ultimately, we're all in this, this is the business for everybody. So I answered that question. Any plans for fiber up the tower? We've had some debates about that. With the coax, we feel that we cover that. Also with the outdoor IDU, the outdoor IDU mount, that would cover that too. And actually, I guess in that situation, if you wanted to mount the outdoor IDU, well, we're still figuring out those details. So for people who have a need for fiber up the tower, the issue with that is it obviously increases the cost because now you're running fiber instead of coax and it becomes a little more messy. But there are the benefits, I guess, of lightning protection on that side. Well, not always though, because you still have to run power up the tower. So, ground potential. Yeah, well, why don't you shoot me an email for the person who asked that question. Shoot me an email offline. I know who you are, so you know how to get a hold of me, and we can have this discussion. And if you want to tell me what other benefits are there and stuff like that, when we start looking at outdoor installations, probably sometime in the spring of next year, I'll definitely keep you in mind. So, because we want to build products that customers want or need. Any plans for compression? We currently support compression. So that's that. Let's see. Next question. Will the new IDU support up to an 80 megahertz channel if a potential 80 megahertz ODU is developed? Currently, this is something that is being debated. Unfortunately, or I don't want to say fortunately or unfortunately, there's, well, with everything, especially with hardware, there's product development cycles. So the IDU, this 1337, actually was the the LL1337. We started development on that back in fall of I think it was it was around the fall of 2011 when we started looking at the chipsets and the dev kits and putting all the pieces together of that. So this new 80 megahertz channel, so let me take that back. At the time, because channel sizes were basically limited to 30 or 40 megahertz, and our 60 megahertz ODU was sufficient, what we thought for the time being, we developed the IDU for 60 megahertz because we said, well, that's probably going to be fine, and when that happens, we'll be able to drive, all the bandwidth and all that sort of good stuff. Now, in the last month, obviously things have changed. And things have changed, but our product development life cycle, we're so close to the finish line. And I don't want to, stop at the 2-yard line and, move back to the 30-yard line. So the chipset actually has those capabilities. They haven't been explored. And right now we're trying to just get the product done and released in the next 60 to 90, 30 to 60 days and get all the bugs and the software kinks worked out. So the answer is, I don't know. Yeah, the honest answer is I don't know, and I'll have to, probably after we release this LL1337, we will then take a look at it and see, well, do we look at expanding the LL1337 to an 80 megahertz channel so that when 80 megahertz ODUs come out, that you can use that? And what are going to be the benefits of that? Will we be able to drive enough out of the chipset? Or, because of the larger channel size, do we start looking at the newer, so right now the the 1000 is based on the Provision 310 chipset. The 1337 is going to be on the 510, and there's this 610 chipset that's been out, that does the, 1024 QAM and all these sorts of, crazy and wonderful things. So we'll have to take a look at that and say, well, does it make sense to go back to this 510 chipset and do additional development to maybe eke out more bandwidth, or should we just look straight on at the newer 610 chipset and drive 1024 QAM on the 80 megahertz channel? So great question, but I unfortunately don't have an answer for you. And again, the person who asked it is someone who knows me. So if you want to contact me offline and have this discussion, I'm more than willing to shoot the breeze, and maybe we can just talk and see what makes the most sense. So with that, I believe I have answered everyone's question. Well, that's good. Looks like we're going to wrap this up. So I want to thank everyone. We had close to 100 registered people, and looks like there's still 30 of you guys who've made it all the way to the end. So kudos to you. I want to thank you guys for taking time out of your busy schedule to listen to us. Hopefully we gave you good information. This webinar has been recorded, so afterwards someone will contact you and give you that information of how to download it and watch it again. And thanks a lot. If you're an existing customer, thank you very much. If you're not, still thank you for coming, and we'd love to find a way to work with you. So thanks a lot, and have a nice day. Bye-bye.